Good morning everyone, it's me Vikas Mandari from Sydney College Group 58. Welcome to our presentation for HEAT 140. Our presentation is all about the finding of bat versus rat projects. In this presentation, we'll explore whether bats see rat only as a competitors for food or if they also see them as a potential predators. Bats and rats often eat from the same food source. To understand their behavior, geologists observed them for the 7 months in a semi-natural bat colony. The key question is, do bats treat rats as a simple competitors for food, or do they act as the rats as a competitors showing for the fear and danger? In this slide, we are talking about why this question matters. This question matters because competition and predation creates very different behavior in rat and bats. If rats are seen as a competitors, bat may just fight for a food. If rats are seen as a predators, bats may avoid them or act more cautiously. In this project, our role was to use the provided datasets, which was the two dataset, apply data cleaning, analysis and hypothesis testing in Python, and then answer this research question.
We work with two datasets. The first contained details of bat behavior on the food platform, such as landing times, how long after rats they arrived, latency to reach food, and whether the bats took risks or gained rewards. The second dataset captured wider information in 30-minute time windows, like total rat minutes, bat landing numbers, and rat arrivals. Data cleaning. To prepare the data, we clean and standardize it in Python. We fix column names, converted dates and numbers, and remove duplicates. We also inserize extreme outliers to avoid distortion. Finally, we created new features like whether a landing was within 60 seconds of a rat's arrival and label for our risk and reward outcomes. This made the data easier to analyze.
Hello, I am Sabine and I will be presenting the descriptive analysis section of our project. My teammates has already covered what we aim to find in this assessment as well as the data cleaning process has also been done. In this part, we focus on visualizing the data to understand bat's behavior towards rat. First, we use histograms of landing times to explore patterns in bat activities. Next, we apply a box plot to examine whether bats tend to avoid interactions with rats. Finally, we use a scatter plot of landing time to analyze whether the presence of more rats influenced the likelihood of bats landing. Through these visualizations, we aim to better understand the relationship between bats and rats if they view each other as predators or competitors. The first histogram shows the time in seconds after the rat arrived for the group of bats that we call avoidance bat. What we can see is the most of their landings happen quite quickly within the first 200 seconds. After that, the number of landings started to go down. The second histogram shows the same measures, but this time for the group of bats we call risk-taking bats. Interestingly, the pattern is very similar. Most of their landings also occurred early and the frequency dropped over time. When we compare these two histograms, it suggests that both group of bats behaved in almost the same way. This matches with our statistical test, which showed that there was no significant difference in landing times between avoidance bat and risk-taking bats. So overall, both groups landed quickly after the rat appeared, and their time patterns were very much alike. The third plot is a box plot that compares the latency to food. In other words, how long it took the bats to actually reach the food. From this plot, we can clearly see the difference between two groups. The risk-taking bats reached the food more quickly, while the avoidance bat often delayed feeding, with some waiting for quite a long time before they finally approached the food. The key point here is the presence of rat didn't really change when the bat landed as we saw in the histograms early, but it did affect how long they waited before feeding. This means that avoidance bats were more cautious, taking extra time before going to food. This supports the idea that rats were being treated as a potential predators by bats. So, even though both groups landed around the same time, the avoidance bat behaved more carefully when it came to feeding. The scatter plot helped us confirm another important pattern. What we found was that when rats were present for a longer time, the bats landed less often on the food platform. This shows a negative relationship between rat presence and bat landing. The longer the bats stayed around, the fewer landings were observed from the bats.
In this slide, I am talking about hypothesis testing. Hypothesis 1, landing time versus risks. Here we check whether bats that avoid rats landed later than risk-taking bats. The result was p equals to 0.439, which is not significant. This means there was no real difference in landing time based on risk behaviors, so landing itself wasn't strongly affected. Hypothesis 2, latency to food versus risk. For this hypothesis, we asked, once a bat landed, did avoidance bats took longer to approach food compared to risk-taking bats? The result was extremely significant, p equals to 9.3 into 10 to the power minus 19. This shows avoidance bats delayed feeding, which suggests vigilance. They were more cautious almost as they saw rats as predators. Hypothesis 3, risks into rewards. Next, we'll look at whether risk-taking behaviors leads to more rewards. The result was p equals to 1.6 into 10 to the power minus 78, highly significant. This means that bats which took risks were more likely to get food, showing a clear risk-reward trade-off. Hypothesis 4, rat minutes versus landings. Finally, we tested if the amount of time rats spent on the platform influenced bat landing. The result was p equals to 1.77 into 10 to the power minus 7. This shows that when rats were around for longer, bats landed less frequently. In other words, more rats lead to fewer bat landings, strong evidence of avoidance behavior. So overall, one hypothesis showed no effect, but the other three strongly supported the idea that rat presence changes bat behaviors in meaningful ways. When we interpret these results, we see that one test was neutral, but three tests strongly supported predators-like behaviors. Avoidance bats were more cautious, risk-takers faced trade-offs, and overall rat presence reduced bat foraging activities. Together, this pattern suggests predator risks rather than simple competitions. To conclude, our finding shows that rats affected bat behavior in way consistent with predators' avoidance. Bats delayed feeding, landed less often when rats were around, and showed a trade-off between risks with rewards. So the evidence supports that bat treats rats not only as a competitors but also as a potential predators.
At the end, we'd like to thank our lecturers and acknowledge the project data brief and ecological concepts that support this work, and all the references that are listed over there are used in this project.